our group will present about nuclear reactions in the sun and the star.
Assalamualaikum
And hi,
My name is
Nadira binti Syamsul.
Star Azwin binti Jamal Nasir.
Nurul Izrin binti Basri.
Nuclear reactions is the process whereby the structure of nuclei is changed after bombardment with energetic particle. The bombarded particle can be an alpha particle, a gamma ray photon, a proton, a neutron, or a heavy ion. So what will happen during the nuclear reactions? So energy will be absorbed or released. In nuclear reactions, the total atomic number and total mass number must be always equal or balanced on either sides of the equations. Nuclear reactions can be divided into two, which are nuclear fissions and nuclear fusions. So nuclear fission is a nuclear reaction in which a heavy nucleus split into two lighter nuclei. So from a heavy nucleus, when nuclear fission happens, it will split into two lighter nuclei that are almost equal in mass with the emissions of neutron and energy. So nuclear fissions release an amount of energy that is greater than the energy released in chemical reactions. For nuclear fissions is a type of nuclear reaction in which two light nuclei fuse to form a heavier nucleus with the release of large amounts of energy. So the energy released in nuclear fissions reactions is called a thermonuclear energy. So nuclear reactions that happen in the sun and star is the nuclear fusions, where the two light nuclei fuse to form a heavier nucleus with the release of the large amount of energy.
Reaction in the star. Nuclear fusion in star. Nuclear fusion is an atomic reaction that fuels star. In fusion, many nuclei, the center of atom, combine together to make a largest one, which is a different element. The result of this process is the release of a lot of energy. The resultant nucleus is smaller in mass than the sum of the one that made it. The difference in mass is converted into energy. Stars such as the Sun are basically hot balls of hydrogen and helium gas that emit light. They are held together by the enormous gravitational forces caused by their own mass. Inside the core of a star, these forces create a harsh environment with pressure more than 1 billion times the atmospheric pressure on Earth. The temperature is hotter than 50 million Kelvin and the density is over 150 times greater than that of water. In extreme conditions, nuclear fusion reaction combine the nuclei of hydrogen atom into helium with a release of energy. This energy flows outward, balancing the inward pull of gravity.
Nuclear fusion is the source of the sun's energy. The sun is a small star which generates energy on its own by means of nuclear fusion in its interior. The field of fusion reaction comes from the protons available in the sun. The protons undergo a set of fusion reactions producing isotopes of hydrogen and also isotopes of helium. However, the helium nuclei themselves undergo nuclear reactions which produce protons again. This means that the protons go through a cycle which is then repeated. Because of this proton-proton cycle, nuclear fission in the sun can be self-sustaining. The figure below shows the set of fusion reactions in the proton-proton cycle. The amount of energy released per cycle is about 25 MeV. Nuclear fusion occurs in the interior of the sun because the temperature of the sun is very high. Involve hydrogen nuclei combining together to form helium. In the process, a small amount of mass is released as energy, and this makes its way to the sun's surface before beaming out into space. The prime energy producer in the sun is the fusion of hydrogen to form helium, which occurs at a solar core temperature of 40 million Kelvin. The net result is the fusion of 4 protons into 1 alpha particle with the release of 2 positrons, 2 neutrinos, and energy.
In conclusions, nuclear reactions that happen in sun and star is the nuclear fusions. This is because in the core of the sun, hydrogen nuclei are combining together to form helium. While for the star, this is a lot of stars, so we look for one star. So in a core of a star, 2 hydrogen atoms fuse to become a helium atom. While for nuclear fission reactions, this does not normally occur in nature because it produces many highly radioactive particles. That's all from us. Thank you very much for watching this video.